Welcome to That's It YouTube channel, my dear students. So today is the ninth session of our JEE advanced preparation. We had started already the organic chemistry and covered comprehensively the concepts related to the general organic chemistry, isomerism and electrophilic aromatic substitution in two parts. Now we have entered into a part where the from where the reaction sequences play the major role. That means reagent oriented questions are mostly asked, and you know that when the questions are asked in JEE advanced, they are mostly sequential. So there is a proper connect between the chapters. For example, you take alkene. When you are adding water, you will get alcohol. When you are doing the Ose analysis, you will get aldehyde. So there is proper linkage from one chapter to the other. So we try to fuse the concepts and explain you the fundamentals by solving the PYQs, and let's pick up the first question of the day. You can see that I am using sodium in liquid ammonia. Just straight away write the reaction, isn't it? You know that sodium in liquid ammonia is used as anti-hydrogenating agent. That is reduction, right? And this reduction in particular you call as Birch reduction, which is used to reduce the non-terminal, that means they are not at the last position. Non-terminal means this triple bonds, isn't it? So it actually gives rise to the trans compound, isn't it? So you got a trans product. So this is your first product. Now we can see that you have treated this with bromine in excess. So since you have taken this bromine, which is also going to add in an anti manner, I want to get the two bromines pointed opposite, isn't it? Anti-addition. Mostly they are anti-reaction, and when I am adding the bromine on the trans product, I will be getting the cis alignment of the hydrogen atom. This you will study in the addition of HX to the alkene or X2 to the alkene, right? Now you can see this substance is being taken and treated with what? Alcoholic KOH. This is nothing but dehydrohalogenating agent. However, this is also anti-agent, anti-eliminating agent. So what you do basically, you are going to carry out the Sadjeff elimination. However, Sadjeff over here is not possible for this removal of bromine, because this hydrogen is also pointed as the bromine. They should be anticoplanar. That's the reason why you need to carry out here, over here, the Hoffman elimination. So I am going to write the product. You please carefully observe. So double bond you will get here, but not here. After that there is a hydrogen atom. So removing that to give you a double bond, isn't it? Now you can see that the product should not contain sp hybridized. That means I am not going to remove one HBr from here and one HBr from here. You are not getting a triple bond here. Only the double bonds are obtained. So I will be removing the hydrogen from here. Alright. So I will be getting one of the hydrogen eliminated from here, double bond. Alright, see, so I am removing one H from here and one H from here, one bromine from here. So I will be getting what? A double bond here, and also I will be removing another hydrogen from here. So I will be getting what? CH, double bond CH2. So you can see that here I wrote a cis compound. Alright, because you can see that there are two hydrogen atoms. One removed, I have one hydrogen removed is the cis product. That means you will also be getting what? The trans product. So total number of isomeric tetraenes that are possible over here, because you see this part is not going to show any sort of geometrical isomerism. So geometrical isomerism lies only here. So you will be getting what? Cis and trans. That means the total number of isomeric tetraenes that are obtained over here are geometric isomers, which are nothing but 2. Okay, let's see the next question. You can see we have taken this substance and treated this with ozone, which is reductive ozonolysis, isn't it? So you are breaking the double bond and you are keeping double bond O and double bond. So what is that you are getting? CS3 CH2 CH2 CH2. That is 2 moles of CH3, CH2, 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 isn't it? So you got butanol. Now this is being treated with KMNO4. You know that when I treat it with KMNO4, easily the aldehydes are converted into the carboxylic acid. So you will be getting butanoic acid. Now this is converted into the sodium salt by treating with NaOH. And after that this is subjected to what you call the very famous Kolbe electrolysis. So this is the question from alkane, right? Alkane is the source of this question. So when you carry out the Kolbe electrolysis of this substance, you can see how you are going to write the product. You have what? C3H7 group attached over here. Now you have got 2 moles of the sodium salt of the butanoic acid and you are carrying out the electrolysis. You know how to write the product of the electrolysis of the salt. You know you will be getting what? NaOH and H2 at the cathode of the electrolysis, plus you will be getting the carbon dioxide 2 moles. Apart from that, you will be getting a linkage between these two. That means what is that you are going to get? C6H14 or simply N-hexane, isn't it? You can see CH3, CH2, 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 CH3. So what is the substance? N-hexane. So this is the product which is obtained after third step. Now this is treated with a very famous reagent, that is Cr2O3. You know that you're going to get what? Benzene. First you will be getting what you call cyclohexane, and that is further heated so that you finally get what? Benzene. So number of methylene groups, that is CH2 groups, initially you will be getting what? The cyclohexane only. However, this will transform into the benzene because of the excess of heating above 500 Kelvin. Hence the final product is benzene but not cyclohexane. So if this is the answer, then if this is the product, then the answer would have been 6. But since you get benzene, the number of methylene groups, you can see that in this product, that is benzene, there are 0 methylene groups. So answer is none. Alright, one of the important question asked in the recent times. Now let's see the next question. The maximum number of possible isomers, including the stereoisomers, which are formed when 1-methyl cyclohexene is subjected to the bromination, right? This is the reactant. Now you have to carry out sequence of reactions. It's a free radical substitution. So there are multiple possibilities, right? So you have to write all possible products and then you have to go for what you call the stereoisomer. So I am writing it on, I'll write them as the position wise. So I am writing at first position. So you will be getting the bromine substituted at the primary carbon, right? Plus, first let me write the direct products. Then you have attacking on second position, bromine attacking at the second position. So you got the second position attack. Then likewise I will be just writing the products. First you write the normal products, fourth and then fifth. Then we will see if there is any rearranged product or stereoisomer, etc. After that, you see, after writing the normal products, you have to identify if there is any chiral center. You can see that this carbon has 4 different groups attached to it. That means you will be getting an enantiomer attached to it, isn't it? As you could see that this carbon is also having the asymmetric center. Therefore, alright, this is having an enantiomer to it. This is also a symmetric center, so there is an enantiomer to this as well, and you can see over here that there is an enantiomer to this as well. So you can see the regular products are 1. Every time you got what? 2 plus 2 plus 2 plus 2. That means there are 4 substances which are giving rise to the optical isomer. So 8 plus 1, 9. After that, you see, once if this radical is formed, what is that radical called as allylic, isn't it? You see, I'll write few of the allylic radicals. What else? CH3, there is a dot here, and you can see that CH3 and there is a dot here. So these are called what? They are in conjugation with the double bond, allylic, isn't it? So I'll be writing the allylic free radicals. You can see that this undergoes rearrangement to give you another free radical. So we need to write the rearranged products also. We will be getting a double bond here and a radical here. So the same sort of rearrangement is taking place out here. So we will be getting what? Double bond here and a dot here with a CH3 here. And that type of rearrangement is also found here. So you have to write the rearranged product. That means these two dots are combining to give you a dot CH3 and a dot. Now you see, when this is subjected to the bromination, so the product which is obtained apart from the regular product is this. And you can see that this is also having a symmetric center, so you will be getting an enantiomer, isn't it? However, you can see that this substitution gives rise to the same product, isn't it? You can see this is same as this. So you need not consider this. Already we have done it there, isn't it? Now you can see that when this is subjected to the bromination, finally you will be getting a substance which has CH3, CH3, then a bromine and a double bond. In fact, this is also having the asymmetric center. So you can see that extra, apart from this 9, we have got 2 here, right? I mean to say 2 here and 2 here. That means total number of isomers which are obtained during this reaction is actually how many? 13 is the right answer for this question. Lengthy but interesting. You have to write all possible. You have to write all possible structure, isn't it? Let's see the next question. The reaction of Q with the nucleophile gives rise to an organic substance that gives a positive Carius test when treated with sodium peroxide and BaCl2. You know, this is a very famous reaction, Mesenheimer reaction, isn't it? So the condition is that this NO2 group, which is very strong electron withdrawing group, should lie at the ortho and para positions of the leaving group. And as far as this Mesenheimer reaction is concerned, in contrast to normal substitutions, alkyl fluorides are more reactive. Remember this. So there is only one apt solution or answer to this is nothing but option A, because when you are treating this with what you call PHS-Na, you will be getting a substance which has sulfur, that is extra element, Lassigne's test. Because these two NO2s are ortho and para to this F, and F will successfully be replaced by these nucleophiles. Now we can see that this, when treated with the sodium peroxide in presence of barium chloride, this sulfur would be oxidized from -2 to +4, giving rise to BaSO4. So this is nothing but your Carius reaction or test. Alright, so right answer for this question is option A. Hope you understood, isn't it? Easy, a bit easy question. Next one, you have to find the value of Y. What is that Y? Maybe the grams of U that is obtained in the reaction, right? Now let's see how this reaction is going, and we should not be concerned about the product, that is R. So let me write the reaction. You know, Mg2C3 upon hydrolysis gives rise to what? You know how to write the products, isn't it? The total charges on this side is 2 into +2, that is +4. So you have to add that many hydrogens here. So the product that is obtained after the hydrolysis of this is nothing but C3H4, which is the propyne. So it is propynide. Alright. So you will be getting what? Propyne. So this is your P. How many gram of that is being taken? 4 gram. Alright. Now you see, this propyne is subjected, I am concerned only about this. Now we know the addition of water to that is in presence of He+2 and H+, that means addition of water. So propyne gives rise to what? You have studied, isn't it? Propyne on addition gives rise to acetone. So you have taken 4 gram and there is 100% yield of that. That means I will be getting what? The 4 grams of this substance, but this is absolutely incorrect to solve the question like this. because when you are calculating the percentage yield, you have to convert that into the moles, isn't it? Now you see this molecular weight of this substance 36 plus 4, that is molecular weight equal to how much? 40. So you have to quickly convert this into what? Moles and solve. Don't solve this in gram. That is the fundamental mistake that everybody commits, right? In all stoichiometric calculation, you have to convert that into mole, right? Then only you can get the right answer, right? So this, don't commit this mistake by straight away writing it as 4, right? So 1 mole gives rise to 1 mole. So 0.1 gives rise to how much? So 0.1 mole. Now next reaction is actually the reaction pertaining to aldehydes and ketones. Since you are preparing or in the final stages of your preparation, so I am assuming that you know this reaction, isn't it? Now what will happen? This is your S. You got 0.1 mole of the S. Now you know this is nothing but the aldol condensation which takes place here in presence of a dilute base. So what will happen in aldol condensation is that you are going to take CH3, COCH3 and carry out the aldol condensation, that is dehydration simply, isn't it? So you will be eliminating H2O and writing the concerned product. What is that product? CH3, C, CH3, double bond CH, C double bond O, CH3. So this is your product T. Now you can see that you have got 2 moles giving rise to 1 mole, right? 2 moles of the substance. So how much you took? Indeed 0.1 mole. So 2 moles are giving rise to 1 mole. So the moles of this obtained is only half, that is 0.1 by 2, but you can see the reaction is only 80% yield. So T obtained is 0.1 by 2 into 80%, that is 0.04. If I am right, isn't it? You can see that, alright. So this value is 0.8, 0.4 and this is 0.04, isn't it? Now you can see that this T is subjected to chloroform reaction. So what's happening here is that you have taken the T, CH3, C, CH3, double bond CH, C double bond O, CH3. This is the substance that is being taken. T is subjected to the reaction with ClO minus. It's like iodoform reaction, isn't it? So this group is responsible for this reaction, where this whole thing will be converted into CHCl3 and rest of the substance is carboxylic acid. So U is a carboxylic salt, not acid even, because you are not doing any hydrolysis, right? So remember that you will get the carboxylic salt which has a double bond, hence it will decolorize the Bayer reagent. So this is your final product U. So you can see you got 0.04 mole of this. Therefore 1 mole giving rise to 1 mole. So you will be getting 0.04 mole of this substance. But you can see only 80% is obtained, isn't it? Another obligation. So you will be getting 80% of this is equal to weight, that is Y gram, divided by the molecular weight of the whole substance, right? You have to write the molecular weight of the whole substance, that is the molecular formula of this U equal to C. How many carbons are there? 1, 2, 3, 4, 5. Alright. Hydrogens are how many? 3 plus 3, 6 plus 1, 7. Alright. 1, 2, 3, 4, 5. Hydrogens are 7. 2 oxygens are there. And 1 sodium indeed. So the molecular weight of this substance is 60 plus 7 plus 32 plus 23. So you substitute the whole value over here. 67 plus 23 is 91, 122. So to find the value of Y. Interesting question, but taking time, isn't it? So you should know the sequence of the reaction. Also you should do the stoichiometric calculation. While doing the stoichiometric calculation, please see how much yield is obtained. Accordingly only you should. Now you can see birth reduction rate. Again the similar question, most frequently asked, meant for what? Terminal alkynes. This is the easier question that is asked in the recent times from JW Advanced. You can see that this won't react, only this will react, and you know that this gives rise to what? Trans, because the addition is anti. You can see that terminal is not reduced, so option A is ruled out and option D is also ruled out. So we have got two choices, C and B, but here the product is cis and here only the product is trans. So right answer for this question is option B. Hope you're following and liking, isn't it? Now let's see the next question based on the Ose analysis, isn't it? Our favorite reaction, alright? So you're doing the reductive Ose analysis. So that means you'll be getting aldehydes or ketones. Reductive Ose analysis. So what you need to do is you have to break the double bonds and attach double bond to double bond every time when you're breaking the bond, isn't it? You'll be attaching what? A double bond to this side as a compensation and a double bond to other side. Alright, do that every time and write the ultimate products, final products, right? As a compensation, isn't it? And you see how many what you call optically active compounds are obtained out of it. You can see now, right? You'll be writing CH3 CHO as your product, which is not chiral, achiral. I write it as A. Now you can see that over here you got CH3 C double bond O. There is a OH and a CH3, and there is a CH3 with a double bond. This portion is done, right? So I am removing this portion so that any sort of confusion can be removed. So I hope you understood how to solve the question. So I have removed it. Now you can see I have done this double bond, and at the other side also I am going to put a double bond. So what you are going to get here, you can see that this linkage is broken. So you got over here, you can see double bond. This I am starting from here, and there is a OH, and you can see that there is a CHO as well, isn't it? Now this part is also done. Now let's see the next part. Plus, right, this part is written, right? CHO. Now you have CH3 C double bond OH CH3 C double bond CH3. Now this part is also we have covered, isn't it? This part also we have covered. Now what is that we are left out? Plus CHO. You can see this group is CHO. OH CH3 C double bond CH3. This part is also done. Alright. So doing it very carefully so that we don't commit any mistake. Very sensitive reactions. Now we can see this part is also done. I'm writing the other part. You can see you have this. You have a OH. Alright. You have a double bond and CH3 plus CH3 CHO. That means you got 2 moles of CH3 CHO. Alright. So you need to write the optically active or chiral substances. You can see this is a chiral. There are 2 substances which are a chiral, and you can see that these 2 groups are same, and this is also a chiral. Alright, you can see that this is COCH3, this is CHO. This is a chiral substance, and this also have these 2 groups equal. So this is chiral, this is a chiral, this is CHO, this is COCH3. Therefore this is also chiral, and these 2 groups are same, isn't it? So you can see that this is also a chiral. So total number of substances which are found here, found to be the chiral, are 2. Alright, so you have to carefully solve these type of questions, isn't it? Now look at this. Hydrogen, palladium, barium sulfate, triple bond would react. What will happen here, that this double bond would be formed in place of the triple bond with that syn addition of the hydrogen atom. This is very important knowing, isn't it? Syn addition of the hydrogen atom. You can see that you are adding over here. alkynes are reactive towards the palladium barium sulfate Lindlar catalyst is nothing but syn addition of hydrogenating agent. So that will give you a cis product. Alright. So you got a double bond, another double bond. Now you see this is added the dilute KMnO4, that is Bayer reagent. You know what Bayer reagent does? It's going to add the OH group to all the existing double bonds, isn't it? And that addition indeed is also what? Syn. That means what? You're going to add OH either from the top side or from the bottom side in the syn manner. So total number of hydroxyl group are 6. So right answer for this question is how much? 6. Got it? Let's see another important question. Consider the transformation reaction, very important reaction. There is an optically active compound R. That means it has 4 different groups attached to it. You have to first of all identify what compound is that, right, which is optically active. The only option which is being given over here says whether that is optically active or not. If it has any chiral center, then it is so, but it is not. Let's see one by one. You can see this substance is being taken and subjected to the reduction. That means that particular product is having this type of arrangement. So you can see that P could be either of these two, isn't it? That means the double bond is conjugated or not, that depends upon the product of this reaction. Alright, so you can see that this is getting complicated until we know what is exactly happening. Alright, so we will solve it like this. We will take the substance, okay, and treating it with NaNH2. That means the triple bond is present at the terminal position, isn't it? And you can see the option would clearly suggest that if R is this, that means you can see that double bond and the corresponding this linkage, the double bond and this linkage is separated by one methylene group. So if P is the right answer, then R also should match to it. But you can see R is not optically active. There is no chiral center present, isn't it? So I can say confidently that this is not P. Then I have only one choice of taking this as P. So I'll proceed with that, right? I'll take this as P and I'll carry out certain reactions on that. You can see that I'm treating it with what? Various reagents. So I'll do one by one. I'll take P and as you know that reduction of this by using hydrogen presence of platinum, Sabatier-Sanderen's reaction will reduce all the pi bond that are present to give rise to this. So this makes sense, right? Next you can see that we have got P. I am writing it with a different color. This is a terminal alkyne. Now we can see the terminal alkyne when treated with the what you call sodamide. That means I have taken this substance and treated with what? NaNH2. You know that this terminal hydrogen will be removed or replaced by the sodium, because you all know that they are acidic in nature. Now after that, you know that this would undergo the nucleophilic addition on the ketone, giving rise to what? A double bond C, triple bond C, isn't it? This is attacking over here, that is OH, CH3, C6H5. Got it? Now we can see in the next step what we are doing exactly is that we are carrying out the dehydration, removal of water. That means I am removing one hydrogen from here and OH from here. So what do I get here? Double bond C, triple bond C, C, C6H5, double bond CH2, isn't it? Alright, am I right? So you can see that if I take this substance, there is a chiral center, isn't it? You know, this is that chiral center which we are talking about. So this is not matching, nowhere there is a chiral center. Alright, so you can see that P is this and X is, you know, you can write that reaction pertaining to this. You can take this substance and treat it with the hydrogen in presence of palladium charcoal, you know, the syn addition agent of the hydrogens. That means you will be getting the cis product CH2. Okay, then this is heated with what? KMnO4. What will happen here when you are heating? Oxidative cleavage, double bonds will break. So what do you get here? You can see that you got this link which is chiral. You can see you will be getting COOH when it is undergoing oxidative cleavage, and you will be getting COOH here as well, and you will be getting CH2, CH2, CH2s, alright, COOH. There are 1, 2, 3 CH2s and COOH. You can see there is COOH, 1 CH2 COOH, 2 CH2 COOH. Therefore, this is the right answer. So option B is also the right answer. Alright, it's a very interesting question, lengthy but very interesting, isn't it? Now let's see the next question. The correct statement for the following addition reactions are, you know, you have been studying, right? You know, you have got a trans substance and you are carrying out what? Anti-addition. So you will be getting what you call M and N. Actually they are identical, isn't it? Trans anti gives rise to meso. You will be getting CS3, HBr and HBr, and when I am writing it like this, actually they are not different, they are superimposable mirror images, you know that they are identical, right? So M and N are same. However, when you do it on the cis, you will be getting the enantiomers. You have studied this as a basic reaction of organic chemistry additions, isn't it? This and its enantiomer you will be getting Br and H, CS3, CS3. So these are O and P. Now look at the question. These are enantiomers, isn't it? Non-superimposable mirror images. Alright. M and O. Here the comparison between these two. N and P are the pairs of diastereomers. That's true. Because you know 50% of the configuration is matching. Over here or over here 50% is matching, isn't it? So A is correct. Bromination proceeds through trans addition of both. Yes, anti-addition. O and P are identical. No, they are enantiomers. So option C is incorrect. M and O, N and P are enantiomers. This is also absolutely wrong. They are actually diastereomers, isn't it? So right answer for this question is A and B. Hope you understood, isn't it? Now let's see the next question. You have got 4 substances and you have to write the correct statement. You can see this is benzylic. When this is going out, this is benzylic and 1 degree. This is normal 1 degree alkyl halide, this is 3 degree alkyl halide, this is 2 degree and benzylic, right? First of all, you need to identify what kind of alkyl halides are they, then only we can write SN1, SN2. Now you can see 1 and 3 follow SN1, right? You know, SN1 goes as per what? The stability of carbocation. And as far as stability of carbocation is concerned, benzylic, allylic, tertiary, secondary and primary is the order, isn't it? Therefore, 1 and 3, this is 3 degree and 1 is benzylic. Hence, 1 and 3 follow SN1 mechanism is absolutely true. You can see 1 is primary and 2 is also primary. Therefore, it undergoes SN2 because for the SN2 reaction, the governing factor is nothing but steric hindrance. And as per that, the reactivity of primary more than secondary is more than 3 degree. Therefore, 1 and 2 follows the SN2 mechanism is absolutely correct. Compound 4 undergo inversion of configuration. Yes, that is 2 degree. This might undergo SN2 and give rise to what? Inversion product. This is also correct. The order of reactivity for 1, 3 and 4. You are comparing here what? 1, 3 and 4 If I am taking 1, 3 and 4 as the context, that means I am comparing with respect to what? SN1. That means I am checking the stability of the carbocation. This is very important. You can see that 4 is 2 degree benzylic, 1 is benzylic and 3 is 3 degree. Therefore, it's absolutely correct as for the stability, right? So, right answer. So, right option for this question is A, B, C and D, isn't it, right? I hope this is the last question, isn't it? Now, I tried to cover maximum concepts through these questions. Hope you are liking the videos, you are following my lectures. You will learn definitely the concepts through these questions. Like there are comments that is it sufficient to score 25, 35, etc. I won't say exactly that is it sufficient to score this many particular marks, but I would say that this would help you even scoring more than what you are exactly anticipating, provided you follow my lectures. After that, immediately practice such type of questions without fail and try to understand the way the teachers solve the question, right? So stay tuned. That's it for today. Keep watching my videos. Thank you.